What's up you guys? In this video, let us work on the basics of logarithms. So the first thing you have to know about log is how to convert between index form to log form. Okay, so here there are two equations here. One is in index form. Index form means indices, in indices form. And then this is in log form. So you need to know how to convert from index form to indices and from index form to log form, and also the other way around. So how do you convert? So when you have index form, you can take the a here. Okay, the a is the base of the indices, right? So you take the a and you bring across. So when you bring across, it becomes a log. Okay, so when it becomes a log, it pushes the b value to the top. Okay, so the a becomes the base of the log. Okay, so you get log a like this. Okay, so log b base a. And you can also do it the other way around. So you can take the a, shift across, so the log base a, right? The a go to the other side, it becomes the index form. So it pushes the x value here to the top. So it becomes the power like this. Okay, so you get a power x. Clear? So this is how you convert between index form and log form. Okay, that's the most basic that you have to know. So let's go through some examples. So you have 3 power b equals to 10. So what I'm going to do, I want to solve for b, right? So I'm take the 3, shift across, so I get b equals to log 10 base 3. Clear? So the 3 now becomes the base for the log. Okay, so the other way around would be, so question 2, what we can do is we can take the 2 here, the base 2, shift across, so now it becomes index form. So you get 2 power 5 equals to k, right? So this is how you convert. All right, next we want to go through the few laws of logarithms. So the two basic law you have to know is, first one is when you add two logs together, okay, when you add two log value together, you are multiplying the value, not multiplying the value, multiplying the whatever is on top here lah. So log a plus log b, that means a times b. Okay, so it becomes a times b. And when you minus, okay, like this here, when you minus, it becomes divide. So a, you end up dividing. So you write as fraction also can. Okay, so this is the opposite of indices. Okay, indices, you learn this when you have, like for example, ax times ay. Okay, so in indices, when it's multiply, you add up the power, correct? You add up the power, so a x plus y. But for logarithm, when it is plus, then you times. So it's totally opposite from index form. Indices, okay, that we have learned. So how do we solve these two examples here? So I'll let you all remember this. I want you all to remember this. When you see negative, when you see minus, just put it at the denominator. That's it. Okay, so for example, you see this, so all of these are base 5, correct? Log base 5. So you can just write the log base 5. Now you got 2 here, you got x here, and you got y. So you can actually write in terms of fraction. So since the 2 here is positive, right? Positive log 2 base 5. So the positive means it's on top. And then here is minus, and then here also minus, right? So minus x, so it will be at the denominator. So it becomes x here. And then this y is also minus, right? So it's also going to be in the denominator. So it's like this. Clear? So just remember, positive means it's at the top, minus means it's at the bottom, denominator. Clear? So it's very straightforward. So let's see the second example here. So all of these are the same base, correct? All base 10. So you can just write back log. So now it becomes what? Here is x, here is x plus 5. Both of them are positive. So if positive, is going to be on top. And then this one is minus, right? So this minus will be at the bottom. Minus 25. Okay, so is this This is the final answer? No, because why? You can still simplify this. So when you simplify, I'm going to write here, you get log, so I can expand this. So I mean, I don't have to expand, I just write it like this, x plus 5, and the bottom here you can factorize, right? So you get x minus 5, x plus 5. Okay, so this is the property, one of the property. When you have a square minus b square, you get a minus b, a plus b. Okay, so this one is x square and 25 lah. 25 is 5 square, so I can break it apart. So now when you have this, you can simplify x plus 5, x plus 5. So you get log x over x minus 5. So this is your answer, right? So let us try some more challenging one. Wait, okay, so before that, now we already done with the first part, which is we combine them, right? So when it's positive, you multiply them, and when it's minus, you divide them. Okay, so it's like this first two law, but it also works the other way around. So that means if it's already multiplied together, you can break them apart to become plus. Okay, or when it's dividing each other, you can break them apart to become minus. So it's actually the reverse form of the formula here. Okay, the reverse form. So let us see. So this first question here, you got log base a, and then in the bracket here you got x square over cert y. So remember, when it's fraction means what? Fraction means minus, right? Divide, so you can break it apart to become minus. So log base a, and then here x square minus log base a square root y. Okay, so there's one property that we have yet to cover, we will cover later, is that when you have the power here, you can bring it in front. Okay, and then you get, actually this y here you can change it to y power 1 over 2. So let me write this, because square root means what? Square root means power 1 over 2, right? So this 1 over 2 can also bring it to the front. Okay, if you don't understand what I'm talking about, later we'll cover. Okay, this is the third law actually. So you get 2 log x base a minus 1 over 2 log y base a. Okay, so this is your answer. So let's see this one. It looks very challenging, right? So what we can do is, this one we can make it simpler first. Because you got square root on the top and the bottom, so we can change the whole equation to y over a square x cube power 1 over 2. Okay, I remove the square root first. So now the 1 over 2 I can bring to the front. Right, this I can bring to the front. So it becomes 1 over 2. Okay, maybe I write here, no space. So 1 over 2. So now in the bracket, I'm going to write this log a y over a square x cube. Okay, so what I'm going to do next is I'm going to break this, because I said when it's divide, you can change it to minus, correct? So we're going to change that. So you get 1 over 2 log base a. So you see here, this one is on top, right? On top means what? On top means positive. So this one I'll just write log y. And then there are two values at the bottom. One is a square, one is x cube. So these two will be minus, right? Because remember from the first example just now that we have done, when it is minus, we put it at the bottom. When it's positive, we put at the top. So the same thing we're going to apply here. So since a square and x cube is at the denominator, so we're going to change it to minus. Minus log a square base a, and then minus again log x cube base a. Okay, so what do you get? Okay, let me write this side right here. So 1 over 2. So log this, okay, we can actually expand this. We can expand this. This 2 here, we can bring to the front. So the 2, okay, I can write the 2 as I write in front here 2 to make it easier for me lah. Okay, so why am I doing this? So this way, by the way, this 3 also I'm going to bring it in front, so I get, later you understand why I'm doing this, because I got no space to keep writing, so I want to make it faster, so I write the 3 here. Okay, bear with me. So anyway, so now I'm going to expand this, expand to all of them. Okay, so 1 over 2 times log y base a, you get 1 over 2 log y base a, minus, so now you got 1 over 2 times negative 2, so you get 1, so you just left it log, so log a base a is what? Log a base a will be equals to 1 also, so you get 1, so minus 1, and then minus, so 1 over 2 times 3, you get 3 over 2 log x base a. Okay, so you can leave your answer like this. Clear? So this is the, you breaking everything apart. Clear? Now let us get into the third law. So the third law is what I said just now. When you have a value in front of the log, okay, you can bring it here to become power. Okay, and it works the other way as well. So if you got a power, you can bring it to the front. Okay, this is just to simplify the log, to make it easier, more simplified. Okay, now I added one thing here. Most people get, most of the students I notice, they get confused between these two. What is the real difference? So log base a, okay, so this is a power n, so this one is a, the whole thing power n. Okay, so there's a difference between these two, they are not the same. Okay, so let me show you what's the difference. So let's say we have, for example, log 5, so log base 5, 3, and then power 2. Okay, so we know that we can take this and bring in front here, right? So we get 2 log 5, so 2 log 3 base 5. Clear? So this is what we can do. So this one will give you what answer? You will get 1.365. When you use your calculator, you get 1.365. So what is the difference between this and this? What's the difference? This one will give you a different answer. This one, the answer you get is 0.466. Now, how is these two different? That's the main question, right? This one here, it means the square, right? This square here is only for the 3. So it's only 3 square. So in other words, you can also write it like this. You can also write as log base 5. So 3 square is 9. So you can actually write this. This one you will get the same answer, 1.365. But if you write it like this, okay, with a bracket, this one means you're going to do log 3 base 5 times log 3 base 5. That means you're multiplying 2 of this to get the square. Okay, whereas for the first one here, the square is only for the number 3. So this one is only for 3. Okay, so that's why you get a completely different answer. They are not the same. The first one here is only for the a value here, and the second one here, the n here, is for the whole thing. So in the end, you will get a different answer. Okay, I hope I didn't confuse you guys. So you have to understand the difference. So let us go through this basic example here. So log 512 base 8. So how can we apply this? So what we can do is 512 we can change to 8 power 3, correct? So 8 power 3, you can bring it to the front. You get 3 log 8 base 8. So when you have same value like this, log 8 base 8, you get equals to 1. So your answer is 3. This one here becomes 1. Okay, so 3 times 1 is 3 lah. So the answer is 3. Clear? So I hope I didn't confuse you guys. So this is the main thing lah. Next, let's look at law number 4. So law number 4 is you need to know how to change base. okay, there will be questions where you need to change the base. So for example, you got log y base x, okay. Let's say the question requires you to change to a completely different base. Let's say you need to change to base a, okay. So what you can do is you write in terms of fraction. The top value here, the y goes up, and the x value here goes down, and then both will become the new base that you want. So if you want base a, then log base a, top and bottom. If you want log base b, okay, then log base b, top and bottom. Okay, so the main thing is the top value here goes to the top and the base goes to the bottom. Okay, you write in terms of a fraction. So that's how you change base. Alright, let's look at some example here. So log 7 base 8. So let's change this to base 10, okay, because there's nothing much you can do here. So we just change to base 10. So log 7. So if I don't write, means it means base 10 lah. So log 7 over log 8. Okay, so the top number comes here, and the base of the 8, the base of the log comes at the bottom. Okay, and then both will have the new base that you want. So base 10, base 10. Clear? So you'll get your answer. Actually, yeah, you can use your calculator and you will get your answer 0.9358. Okay, now let's look at B. So 16 and 64, they have something in common, right? You can change them to become base 4 or base 2. Okay, I'll change to base 4. So base 4 means we know that 64, so we can change to base 4, right? So log base 4, log base 4. So on top here will be 64, but I don't have to write 64. Why? Because I can change 64 into 4 power 3. Okay, and then 16 is at the bottom, but I don't have to write 16. I can write 4 power 2. Okay, so this 3 here we can bring to the front, and this 2 here we can also bring to the front. So in the end we are left with 3 log 4 base 4 over 2 log 4 base 4. So log 4 base 4 will become 1, and here also becomes 1. So in the end your answer is 3 over 2. Clear? Alright, so this is pretty straightforward. We are using the fourth law. We want to change base. So let's look at the next one. Oh yes, there's one more thing that I forgot to talk about just now. It is two of the very simple, most basic properties you have to know. So whenever you see log something base something, right? Let's say both of them are the same value, it is always equals to 1. Okay, so regardless if it's, for example, log 3 base 3 is equals to 1, or whether it's log 5 base 5 is equals to 1. Okay, when you see they are the same value with the base, that means it's equals to 1. Okay, so that's what happened. That's what we did just now. Whenever we see same value to the base, we always make it become 1. The second thing is, whenever you see log 1, okay, log 1, regardless the base, whether it's let's say log a base 1, you always get 0. Okay, regardless of the base. So it can be, for example, log 1 base 3 is equals to 0, or log 1 base 7 is also equals to 0. Anything with log 1 will always be 0 regardless of the base. Okay, so these are the two I wanted to add in just to make sure you all understand. Okay, so now let us go through some actual equation questions, okay, and see how we can implement the 4 laws here to solve the questions. Right, so the first type that you have to know when it comes to solving log equation is when you have equal base, when you can change it to become equal base. So this is quite similar to indices. Okay, so indices, so the first type is you want to try to make it become the same base, because when it becomes same base, it's very easy to solve. So we'll try to do that for this. Okay, so here is log base 2, here is log base 2, correct? So we know we can combine these two log. Okay, so the only thing that is odd one here is the negative 4. So what you're going to do is bring the negative 4 to the other side, and we'll try to combine this log base 2. But before that, we have to bring this up here, because with the 2 there, you cannot do anything. we cannot combine the log, correct? So we have to bring it to the top first. So in the end, you will have log x square, okay, base 2 minus log base 2, and then here is x over 2 minus 1 equals to positive 4. Okay, so now both of them are base 2, so you can combine them. So remember, this is what the first two law, right? Law 1 and law 2 we talk about. Positive means on top, minus means it's at the denominator, so it becomes log base 2. So now the equation is what? X squared at the top, and at the bottom is x over 2 minus 1 equals to 4. Okay, so what do we do next? So what we can do next is, since this is a log equation, okay, so only one side got log, the other side got no log. So what we can do is we can take this 2 here and bring it across. So this is the first thing we talk about, right? We want to change log form into index form. So it becomes x squared over x over 2 minus 1 equals to 2 power 4. Okay, so 2 power 4 is what? 2 power 4 is 16. So I just write here 16. Okay, so I bring this up here now. So I get x squared equals to 8x minus 16. Okay, just multiply. So I rearrange this. I get x squared minus 8x plus 16 equals to 0. So now I can factorize this. So when I factorize, I should get x minus 4 square. Okay, so this is it. Yeah, correct. X minus 4 square. So from here I know x is equals to 4. Okay, so this is how you solve. So the first step is you try, because it's already the same base, okay, equal base, so you can put them all together. Okay, so now the second type we want to learn, we want to solve, right, using unequal base. So if it's unequal base, that's why we learn about the steps to making it equal, correct? We want to make it become equal base. So let's look at the first example. This is base 2, this is base x. So base x, we can't really do much, right? But we know that here 16 can change to base 2. So what we're going to do is we're going to change this here, change it to become base 2. So it becomes, so log x 2, okay, base 2. So here we're going to change to fractions. Remember, the 16 is on the top and the x is at the bottom. Both will be base 2 because we want to change it to base 2. So what do we do? So now this one here, we can bring it to the top because they are the same, right? So it becomes what? You are multiplying the same thing together, so it becomes square equals to log 2. So 16 is what? 2 power 4. Okay, 2 power 4. So the 4 I can bring it to the front, correct? So I get 4 in front here. Okay, so what do I do is log 2 base 2, it become 1, right? So you only have 4 on the right hand side. So this square I can bring it across. So log x base 2 equals to square root 4. So square root 4 will give you two answers. One is positive, one is negative. So the first answer here is log x base 2 equals to positive 2, and the second answer is negative 2. Okay, so this 2 here we can bring it across. So x equals to 2 power 2, answer is 4. This one will be x equals to 2 power negative 2, you get 1 over 4. Okay, so you got 2x value. So this is how you solve. So this second part here is we want to try to make it become the same base. Okay, we have to change the base because it is unequal base. So let's look at question B. So wait, oops, sorry, I just want to divide this so that we don't mix it up. So from here you can see here is base 2, base 4. Okay, so what we can do is we can change the base 4 to base 2, correct? Because both can become same base, right? So you try to make it become equal base first. So on the left hand side you have log 5 z x base 2 plus log, I just write back 16x over log 2, log base 2, and then the 4 I can write 2 power 2, right? 4 is 2 power 2, so the 2 I bring in front here, equals to 6. So here this one becomes 1. Okay, so what do I have? Now I have log 2 5 set x plus 1 over 2 log base 2 16x equals to 6. Okay, so this 1 over 2 I can actually bring it in front here. So what happens is it becomes power 1 over 2. So this whole thing power 1 over 2. Okay, why do I do this? Because now that they are the same base, I can put them together. So it becomes log 2. So this one is plus, right? Plus means you have to multiply the values. So 5 set x multiply. So this one, if I write square root, right? Because power 1 over 2 means square root. So if square root of 16x is equals to 1, so you get 4 set x. Okay, so I write here 4 set x equals to 6. Alright, let me erase this. So next step we can do is we can bring the 2 across. So you get 2 power 6. 2 power 6 is 64. Okay, 2 power 6 is 64. Here you get 20. 5 times 4 is 20. X set x times set x is x. So x is equals to 64 over 20. So x is equals to 64 33.2. Okay, so this is your answer. So let's look at type 3. Type 3 is log within log. So when you see here, you see there's log base 3, and then inside there's another log here. And you see the question B, you have log here, you have another log here. So what do you do? So in this case, what we do is, since there is no log on the other side, we can convert this log form into index form, like what we mentioned just now. So we can just shift one by one. So you shift, the first one you shift. So here you have log base 2, 2x minus 1 equals to 3 power 2. Okay, so 3 power 2 is 9. So then you're going to shift this. So you get 2x minus 1 equals to 2 power 9. Okay, so from here you can find x lah. So x is equals to 2 power 9 plus 1 divided by 2. So you should get your answer. So it's going to be a big number lah. So the answer is 256.5. Okay, so this is your x value. Now let's look at b. So b is the same thing, but in this case you've got log base 9 set 3. Okay, on the right hand side. So what do you do? So in this case, we can try to make it become the same base, but for this question we don't have to, because this is the same as, you can actually simplify this. Okay, so normally how we would solve is, we try to make these two the same base, and then we can try to solve it lah. But in this case, since this one here we can simplify, so we're going to simplify that. Okay, so you have log 9 and then 3 1 over 2, right? Set 3 means 3 power 1 over 2 lah. So the 1 over 2 you can bring it to the front. So you get 1 over 2, and then I'm going to change this to base 3. Okay, I'm going to change it to base 3. So you get a fraction. Okay, you get a fraction. On top here is log 3, bottom here is log 9. Okay, because this one will be on top, this will be at the bottom. So both you want to change to base 3, right? So here is base 3. Okay, the 9 I can change to 3 square. Okay, so this one becomes 1, and then this 2 I bring to the front, and then this log 3 base 3 becomes 1. So I will have 1 over 2 and then times 1 over 3. So I get 1 over 6. Okay, so this one here is equals to 1 over 6. So now I can bring the 16, bring across. So I get what? Log base 2, and then here is 5x minus 4 equals to 16 power 1 over 6. So 16, correct. 16 power 1 over 6 means the sixth root of 16. Okay, that means like this. So that means this answer here is 2. Okay, so before I write 2, this one I can shift across, so I get 2 power 2 equals to 5x minus 4. So what we can find is 4 then plus 4 over 5. So your answer is 8 over 5. Okay, so the main thing is when you see log within a log, you try to shift one by one to the other side. Okay, that's our plan. But if you can't, then we try to make both become the same base, same log base. Okay, but in this case I don't have that question. But the main thing is we try to shift one by one. Clear? Alright. So the last type that I want to show you guys here is when you have log plus indices. Okay, this is a bonus one that I want to share because it's not so common, but I think it will be useful for you guys lah. So when you notice that the log now becomes the power, you see all this while we solve log as the basic form, right? Now you're going to have log as the power of an indices, okay, of a number. So when you get this, right, see when you notice that the base of the log is same as the value of the base number of the indices, okay, you can eliminate both of them. Okay, you eliminate both of them, so your answer is x. Clear? So this is something that sometimes you might encounter this kind of question, so at least you know how to solve. So when you see that the base of the log is the same as the base of the indices, you can cancel it, so you get the top value there, so which is x. Okay, so let's solve the example. So you see here, you got 5 power of this, okay, and then here you got 9. So what we can do is we can add log. We don't have to do anything because why? Here is 5 and here is log 5, correct? So one is base 5 for the log, and the indices is also base 5. So you can cancel both of them. So you just take this. So you get t minus 1 equals to 9. So t is equals to 10. Okay, this is a basic question, very straightforward. So now let's see question B. Now you notice this is 5, this is t minus 1, right? So how do you solve? They are not the same. So what we can do is add log base 5 to both sides. Okay, so I'm going to add log base 5, and then here is 5 power log t minus 1, 8. Okay, so I know it's very confusing, but just bear with me first. I'm going to add log base 5 on both sides. Okay, I'm going to add log base 5. So remember what I said just now? When you have the power here, this is the power for 5, right? So I can bring this to the front. So I get log base t minus 1. This is 8. Okay, this is the first one here. And then the left on here you get log 5 base 5. Okay, because I bring it to the front already. And then here is log 5 base 8. Log 8 base 5. Okay, so this one becomes 1. Okay, so now you have log t minus 1 base 8 equals to log 5 base 8. So what we can do is, you notice here is 8, here is 8, right? So since both of them is 8, so we can assume that this is equals to this, correct? So you know that t minus 1 is equals to 5. So t is equals to 6. So that's about it. So we have already covered the basics of log and also these 4 common types of log questions when it comes to log equations. Okay, so I hope I hope you guys find this useful. Okay, I hope I didn't confuse you guys, but if you all need any more clarification in this video, just let me know in the comment and I will try to explain to you guys further. Okay, so that's all. Hope you find this useful and I will hope to see you on my next video. Take care. Bye bye.